Okay, for number 60, I'm going to go to the whiteboard and go through the steps that I would go through if this was an exam question. All right, let me pull this up to the whiteboard, and we're doing problem number 60 now. I'll write this over here, 60. And it's an integration problem. It's 2x plus 7 over x plus 1, x squared plus 9 dx. First thing we do is partial fraction decomposition. Try to break the integral up into two pieces. One will have a linear factor, the other will be what's called an irreducible quadratic. So x plus 1 plus x squared plus 9. Again, x squared plus 9 is an irreducible quadratic that has complex roots. It's going to be a. This will be bx plus c. I'm going to clear the fraction. What do you get? 2x plus 7 equals a times x squared plus 9. I'm multiplying both sides by the LCD, by the way. That's going to be bx plus c times x plus 1. I'm going to pick an easy x. And what I mean by that is an x is going to make something disappear on the right side. I'll pick minus 1. What does this give you? It gives you 5, and then you're going to get 10a, right? The second term, the bx plus c times x plus 1, disappears. Do I know what a is? I do. A is 1/2. I'm going to pick another easy value. I'm going to pick 0. What do you get? You get 7 if x is 0 on the left side. On the right side, you're going to get 9/2. Again, the reason I say that a is 1/2, and if x is 0, you get 9 times 1/2, which is 9/2. And then what do I get plus c. Again, if x is 0, the b disappears. And then what do you get? You get 1. So I think I can handle this. Let me go through that with you. 7 is going to be 14/2. So that's going to be 5/2. Now when I say that, c is going to be 5/2. So let me just go through that with you. 9/2 plus 5/2 is 14/2, and 14/2 is 7. I still don't know b, so I'm going to pick another number. What number am I going to pick? I'm going to pick 1. What do you get? You get 9 on the left side. On the right side, you're going to get 10 times a, which can be 5. Then you're going to get b, because x is 1. C is 5/2. And again, if x is 1, I get a 2 over here. Well, this doesn't look so bad. 9 equals 5 plus 2b plus 5. And what do you get there? 5 plus 5 is 10. So you get minus 1 equals 2b, or b equals minus 1. All right? I'm sorry, minus 1/2. All right, I got to go up here and write this down now. It's a lot of work, but we'll put it down. So it's 2x plus 7 over x plus 1, x squared plus 9 is equal to a. Well, a turned out to be 1/2. So I'm going to write this as 1 over x plus 1. I'm going to pull the half on the outside. And then what do you get? Let's take a look, be careful about it. The b turned out to be minus 1/2. So I'm going to pull out a minus 1/2. And you're going to get x squared plus 9. And then you're going to get x over here. And the c was, what was c? Oh, 5/2. So this will be minus 5. All right? So what I want to do now is do the integration. All right, I'm going to write it down for you. And I'm going to write it down right over here. Put the dx here. I'm going to put the dx here. I can put the dx over here. All right? So can I integrate that? Well, maybe not. It's totally written. I think I can do the first guy pretty simple, right? So it's going to be 1/2 the natural log of the absolute value of x plus 1. Right. The next guy is a little more complicated for me. I'll tell you why. I see it as two terms now. So 1 minus 1/2. I see x over x squared plus 9 dx. And then I see this over here. I see minus 1/2. I'm sorry, plus 1/2. 5 over. You know what? I'm going to pull a 5 out and get my eraser out again. And I get 1 over x squared plus 9 dx. All right, let me keep moving. And again, to do it, I'm going to do this middle guy first. I'm going to say u equals x squared plus 9. Now, what I'm going to say is a lot of people do this in their head, and there's nothing wrong with that. And du would equal 2x dx. I can put the 2 here and a 4 here. Same thing. So I kind of see it now. Let me kind of get my eraser right. I'm kind of getting into the way of my work over here. So 1/2 ln absolute value of x plus 1 minus 1/4. And I want to use guys antiderivative now. And I see the du over u. So it's going to be the natural log of the absolute value. And now it's going to be x squared plus 9. All right, take a moment to think about this. And look at the other guy, and it reminds me of arctangent. And the way I like to do it may be different than other people, but I'm going to write this down 5/2. And I'm going to factor out a 9. That's 1/9. This will be 1 over x divided by 3 squared plus 1 dx. I'm going to keep working on it. And I'm going to say 1/2 natural log absolute value of x plus 1 minus 1/4. Well, one thing I know about x squared plus 9, it's always going to be positive, so I can remove the absolute value symbol. Let me do this over here, and I'm going to do it by u substitution. I'm going to say u is equal to x over 3, and that means du would be 1/3 of a dx. Oh boy, let's take a look at that. So I'm going to take from the 9 a 1/3. Okay, let's write this down now. What do you get over here? You get plus 5/6. And then you're going to get the arctangent of u, which is x over 3, plus some constant of integration. Put a box in this, and let's look at the key, see how we did. And this is problem number, what number was that? I think this was problem 60. Let me go back and make sure I'm saying that, because I'm going to look back at the key now. A lot of work, though. Let's take a look. Am I seeing this? 1/2, yep, I'm seeing that. Am I seeing this part? Yes, I am. Am I seeing this 5/6 arctan, x over 3 plus c? I'm seeing that. Good to go on. Thank you.